Hey guys, it's Miss Fendley. I'm in Alaska. I think the sun rose around 8:30 today, so it might not even be up yet. We gotta figure out how the so they're 1 hour behind. Excuse me, we're 1 hour behind you now. Um, I think we're going to the North Pole today. We're gonna get to meet Santa Claus. It's either today or tomorrow. I'm pretty excited. I'm gonna go tour the College of Math and Science and the engineering building, which I am like genuinely super excited for. I am also trying to uh, upload that video or yesterday's video to YouTube right now, and my computer is not a huge fan of that, so it's struggling a little. But we're gonna do our best and see what happens. Um, see what happens. I don't know where that video's at, but maybe we'll find it. All right, so today we are looking at reflections. Our second transformation. Yesterday we looked at translation. So our learning objective is to be able to reflect figures in the coordinate plane, perform glide reflections, and identify lines of symmetry. So when you think of the word reflect, right, what do you think of? Like looking in a mirror, right? So the word reflect means to mirror or to flip. If you flip something across a line, mirror it. And get this is going to be a wild one. The line that the figure is reflected across is called the line of reflection. Good stuff, man. Good stuff. The line of reflection. Okay? So when basically the line of reflection is acting as the mirror. So if you take a moment, think about when you're at home, you're brushing your teeth and you're looking in the mirror. What do you notice? Not about you, but about the stuff around you. Okay? So if you're looking in the mirror, and in real life, let's say that you've got your shower curtain that's 2 feet behind you. In the mirror, the shower curtain is 2 feet behind you, right? So the objects in the mirror are the same distance away as they are on your side. So in this example, if line M is your line of reflection and point P is being reflected across point M, it's this far away on this side. So when you reflect it over, it's the same distance away and becomes point P prime. Remember from yesterday, we called the transformed points primes. Okay? So point P becomes point P prime. I'm really hoping this uploads right because I don't really know what I'm doing. Should have uploaded it to my teacher channel, and I tried to upload it to my personal channel, I think, but now it's all angry and hang on. It's not frozen up anymore though. That's exciting. Isn't it fun when I get just as distracted on videos as I do when I'm in class with you? think I just told it to upload 2 videos at one time on accident. Oh, it's going to be a day. Okay. So, when we're on the coordinate plane, we've got 6 common lines of reflection. The lines that we're going to be reflecting over pretty much all the time. You can't reflect across any line, but we like to keep things simple, so we don't. We're going to reflect across the x-axis and the y-axis, okay, because those are easy to reflect across. X equals k and y equals k, where k represents a number. So k, x equals 4, x equals -2, y equals 6, y equals -7. So k is just a number. Okay. So think a moment. Y equals k. That's really just like y, like a slope of 0. So y equals 0x plus 7, for example. So y equals a number. So when the slope is 0, that's a flat horizontal line. Okay, so y equals k, y equals a number is a horizontal line. And x equals a number, well, that's, remember Slope Man, he's walking along, he comes to the vertical cliff, he falls over and dies, right? So x equals k is a vertical line. It cannot be written in slope-intercept form. Okay, so x equals k is a vertical line. Okay. And then the last two are y equals x and y equals -x. These two tend to confuse folks, but they really, really shouldn't. So in y equals x, think about what is the slope. What number is invisibly in front of x? And what number is invisibly being added to the end? Okay? So that's really, y equals x is really just y equals 1x plus 0. So your y-intercept is 0. Your slope, your rise over run is 1. So rise 1, run 1, rise 1, run 1, rise 1, run 1. So that's just a line going up 1, right 1, up 1, right 1, through 0. The next one, y equals -x. Well, that's a slope of -1. The y-intercept is still 0. So a line going through 0, going down 1, right 1, down 1, right 1. So it's just again, just a diagonal line through 0, going down, but going down 1, right 1, down 1, right 1, down 1, right 1. And we'll look at that in just, actually, let's look at it now. If you look down at the bottom of your page, you have those 4 examples. The last two, y equals x, y equals -x. So notice on y equals x, your y-intercept is 0, and you go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. On the D example, y equals -x. So your y-intercept is 0, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. So that's all y equals x and y equals -x are. Okay. If you remember yesterday, we looked at translation rules. We said xy maps to x plus a, y plus b. So a rule is just a shortcut for notation. For finding points, how do we get from point A to point A prime without necessarily having to graph the whole thing? Okay, so we are going to look at 4 reflecting across the x-axis. I'm going to make my pen smaller so I can write a little finer. So we're going to look at reflecting across the x-axis, reflecting across the y-axis, we can't really write rules for x equals a number and y equals a number because those are just any vertical or horizontal line. It can move around. So then we're going to look at a rule for reflecting across the line y equals x, and across the line y equals negative x. Okay, so for reflecting across the x-axis, if you take a moment before we write it down, let's look at this example of JKL being reflected across the x-axis. So point J is at the point 1, 3. J prime is at 1, negative 3. Let's look at L. L is at the point 3, 1. L prime is at the point 3, negative 1. K is at the point 4, 4. K prime is at the point 4, negative 4. So notice in all of those points, when we reflect across this x-axis here, the x's stay the same, the y's become negative. So 3 became negative 3, 4 became negative 4, 1 became negative 1. And that is true no matter which way you're reflecting, that the x stays the same, the y is negated. Okay? So the rule for reflecting across the x-axis is xy maps to x negative y. So x stays the same, y is negated. Now, here's the secret. Your other option is counting. Let's look at J. J is 1, 2, 3 units away from the x-axis. So we're going to go 1, 2, 3 units on the other side. K, 1, 2, 3, 4 units away from the x-axis. So we're going to go 1, 2, 3, 4 units on the other side. L is 1 unit away. Oops. Dang. L is 1 unit away from the x-axis. L prime, 1 unit on the other side. And it doesn't matter if we're reflecting up or down. It's how many units is it to the x-axis? That many units on the other side. Or the x stays the same and the y is negated if you prefer using the rule. And I'm going to go back to highlight that because I accidentally erased it. The y-axis, the rule for the y, reflecting across the y-axis, let's look here. So J, K, and L has stayed the same, but now we're reflecting across the y-axis. Whew, that is real thick when it's super zoomed in. Okay, so J is still at 3, 1. J prime, oh, excuse me, I cannot do numbers at this time of night. J is at 1, 3. J prime is at negative 1, 3. K is at 4, 4. K prime is at negative 4, 4. L is at 3, 2. L prime is at negative 3, 2. So in all of these coordinates, the y coordinate stayed the same, and it was the x coordinate that was negated. So the rule for reflecting across the y-axis is the xy maps to negative x, y. All right? The y coordinate stayed, it was the x coordinate that changed when you reflect across the y-axis. And again, shortcut, I don't know which one's the shortcut, whichever your brain prefers. You can just count. K is 1, 2, 3, 4 units from the y-axis. So we're going to go 1, 2, 3, 4 units on the other side. J is 1 unit away from that y-axis. So we're going to go 1 unit on the other side. L, 1, 2, 3 units away from the y-axis, 1, 2, 3 units on the other side. Okay? So you can count to the line and then count the same distance across, or you can say, okay, I'm just going to swap the sign on the X. Whatever works best for your brain. How do you tell if it's uploaded or not? Like, there's no visual, no nothing. Oh, my battery's about to die on it, though. I should fix that. Hang on. Maybe I should get to you try it. No, I should. Okay. Lord, I'm the most distractible person I've ever met. Ooh. Come on, charger. You're longer than that. Okay. So that's charging. I'm not going to risk a computer dying mid-upload. All right. So reflecting across y equals x. So let's check this out. First thing that I want you to notice, point K is on our line of reflection. So K prime is on our line of reflection. So think about it. If you're standing in front of the mirror and you reach out and touch the mirror with your finger, your reflection is also touching the mirror. So if a point is on the line of reflection when it's reflected over, its prime is also on the line of reflection. All right? You just put them on top of each other. Okay, so, this is not a good triangle to represent this, but let's look at J. So point J is at the point 3, 1. 1, 3. J is at 1, 3. That is like the 12th time I've done that tonight. 1, 3. And J prime is at 3, 1. Okay? L is kind of redundant. L is at 3, 1. L prime is at 1, 3. K is at 4, 4. K prime is at 4, 4. So it's not the greatest example to illustrate it, but notice that between J and J prime, 1, 3, 3, 1, the X and the Y just swapped places. So the rule for reflecting across the line Y equals X is XY maps to YX. 1, 3 became 3, 1. All right? And 4, 4, well, if you swap 4, 4, it's still 4, 4. So that's why K doesn't move. Okay? All right. So I'm going to show you guys a couple of different countings with the diagonal lines. You got some options here. The first option is you can count diagonally. So 1 diagonal to the line, 1 diagonal on the other side of the line. Be careful though, because sometimes you may have half diagonals if you're counting diagonally. So let's just say, for example, that you were reflecting this pink dot here that's at the point -1, 2. If I wanted to reflect this across by counting diagonals, that's 1.5 diagonal. So I'm going to go 1/2 and 1 diagonals on the other side. Or you could just say -1, 2 becomes 2, -1. Whichever floats your boat. The other option, that seems like a bad choice. The other option is to count down. So down 1, 2, and then take a right turn, and then go 2 on the other side. So when you're doing this one, and we'll look more at that on the y equals -x is a better example, you'd count vertical or horizontal to the line and then take a 90-degree turn and count the same distance on the other side of the line. Again, we'll look at the next example for that. All right, so looking at the next example though, so point J is at 1, 3. Said it right this time. When we're reflecting across y equals -x, J prime is at -3, -1. K was at 4, 4. K prime is at -4, -4. L was at 3, 1. L prime is at -1, -3. So not only did the coordinates swap like they did on y equals x, they're also negated. Swap, negated, swapped in, negated. Okay? So the rule for reflecting across the line y equals -x is xy maps to -y, -x. Swap the coordinates and change the sign. If they're negative, they'll become positive. If they're positive, they become negative. So those are your rules, which I think they're shortcuts. Some folks like them, some folks don't. I would not recommend trying to memorize them because you're going to end up with you got one rule for translating, 4 rules for reflecting, 3 rules for rotating, and a rule for dilating. So I would not recommend trying to memorize the rules, but if you have them written down and you're allowed to use a page of notes on your test, it's not a bad deal, right? Okay, so take a moment, make sure you've got all of those written down before I move over to look. Actually, I'm just going to move over and then I'll come back to that, okay? So this is a better illustration of reflecting across the diagonals. So if I want to get from J to J prime, my first option is count the diagonals. 1, 2 diagonals to the line. So 1, 2 diagonals on the other, and there's J prime. Same thing with L and K. So with K, 1, 2, 3, 4 diagonals to the line. So 1, 2, 3, 4 diagonals on the other side. Oops. My other option, if we don't like counting diagonals, because sometimes, remember, you will have to count halves. It's like, if you've got to reflect from here to here, you're going to have to count that half. But the other option is vertical and horizontal counting. It doesn't matter which direction you go first. So if I started at J, I'm going to go 1, 2, 3, 4 units down to the line. So then it's going to be 1, 2, 3, 4 units on the other side of the line. I take a 90-degree turn on the opposite side of the line. So I can't turn right because that's not on the opposite side of the line. That's on the same side of this line of reflection. Okay? I can't go up because that doesn't take me towards the line. I could have gone left and then down, or I can go down and then left. It doesn't matter which order you go in. You just go to the line, then take a 90-degree turn on the opposite side of the line, and that'll get you there. Okay. You do the same thing for K and L. For K, go down 1, 2, 3, 4, 5, 6, 7, 8 to the line. So 1, 2, 3, 4, 5, 6, 7, 8 on the other side. Or you can go 1, 2, 3, 4 to the line, 1, 2, 3, 4. So diagonals, or count down and then over, over and then down, or just use the rule. XY maps to -YX, swap the coordinates and negate them. 1, 3 became -3, 1. Or excuse me, -3, -1. Swapped them and negated both of them. All right. So I'm going to pause there for just a moment. Make sure that you are caught up. If you need more time, just have Ms. Hallberg pause the video. All right. So flip it over and let's look at an example. together. We're going to look at 2 examples and then I'll have you guys do the you try. So first example, it says graph triangle ABC with vertices A at 1, 3. So A is at 1, 3. B is at 5, 2. And C is at 2, 1. Okay, so plot those points. Connect them. Use your straight edge because you don't have a cool tool like mine that makes your line straight. I have 5 subscribers. I don't know what they're subscribing to because I don't post anything. Interesting. Oh, trying to navigate YouTube still. Sorry, guys. All right, so we got ABC plotted and its image after a reflection in the line x equals 3. Okay. So x equals 3. What type of line is that? Take a moment, turn to your neighbor. What type of line is it? Okay, so x equals 3 is a vertical line. The only point that it is going, or the only axis it's going to touch is the x-axis at 3. Okay, so I'm going to draw my line of reflection through 3 on your x-axis. So x equals 3. Okay, remember it cannot be written in y equals mx plus b form anyway, so it's a vertical line. Okay, so we're going to reflect the triangle ABC across this line. Oh, that's a good color. Green's a good color. Hopefully it shows up. Sometimes it's debatable whether that shows up or not. Yeah, this one will. Okay, so A is 1, 2 units from the line of reflection. So I'm going to go 1, 2 units on the other side of the line of reflection. And that will be what? A prime. A prime. Okay. B is 1, 2 units from the line. So I'm going to go 1, 2 units on the other side of the line. And that will be B prime. Remember, always label your points. Always, always, always label. C is 1 unit from the line. So I'm going to go 1 unit on the other side. And that is C prime. Then I connect those points. And even though it's on top of each other, the line has been the figure has been reflected across. Okay, so you're reflecting, if it's on the left of the line, you reflect it across to the right. If it's on the right of the line, you reflect it across to the left. That's really loud and crunchy. Okay, so that's how you do reflecting across the line, x equals 3. All right, make sure you got that down. Spending so much time going. I really hope it doesn't overheat. How long does it take for a video to upload? I mean, it is a long one, but I wish there was like some kind of like metric where I could see the video uploading. This doesn't seem normal. I don't know. Okay. So on an example 2, it says to graph segment AB with endpoints A at 3, -1 and B at 3, 2, and its image after reflection in the line y equals x. So let's plot those points. A is at 3, -1, and B is at 3, 2. Okay. B is at 3, 2. Okay. Connect those points to make your line segment. The line of reflection is y equals x. So remember, that's my y-intercept of 0, slope of 1. So rise 1, run 1, rise 1, run 1. Okay. And then you can take that, once you have the pattern established, you can take that in the opposite direction. And then use your straight edge, because when you're counting coordinates, you really do want to, be precise. So try to get that as straight through the corners of those points as you possibly can. Okay. It's not going to be perfect, and that's okay, but as the best you possibly can. Okay. All right. So if you're using the rule, the rule for xy, or for reflecting over y equals x, is xy maps to yx. Xy maps to yx. That seems pretty handy. So I'm going to use purple. So if A is at 3, -1, A prime is at -1, 3. You just swap them. -1, 3. That would be A prime. And if B is at 3, 2, B prime is at 2, 3. You just swap the coordinates. And that's B prime. So when you connect them, if you were to put a mirror on this line of reflection right here, so that you were looking like you saw AB in the mirror, A prime, B prime is what you would see. And if I was here, we would actually do that. We'd pull out, I've got a bunches of tiny little mirrors. We'd set them on our paper and look at it. But for now, you're going to have to use your imagination. Sorry. All right, so you guys do the U-try. Graph triangle ABC with the given vertices and its reflection, and its image after reflection in the line y equals 3. So before you start, y equals 3, y equals a number. What type of line is that? Okay, you might have to check earlier in your notes. Take a moment, look it up if you need to, see what you can find. All right, and then go ahead and do the U-try. Oh, Lord above. Just found the time count, and it says that it's going to take 2 hours and 45 minutes to upload it. I don't have that kind of time. I want to go home. Oh, I forgot to set a timer. Hey Siri. Set a timer for 1.5 minutes.
Okay. Your timer is set for 1 minute and 30 seconds.